Welcome to my KCC Division channel, Teacher Marita, People's Voice School. Kindly subscribe my channel, click the notification bell to get notified once I upload a new video. Today we are looking at Electrochemistry Part 2, and that is the quantitative treatment of electrolysis. In this quantitative treatment of electrolysis, we are using the Faraday's first law of electrolysis. And this one, Faraday's, is the quantity of electricity carried by 1 mole of electrons, which is approximately 96,500 coulombs. So in this case here now we are using the Faraday's first law of electrolysis. The law states that the mass of a substance produced during electrolysis is directly proportional to the quantity of electricity passed through. So in this case here, we have some of the questions here that requires to use the first law of electrolysis. So in an experiment, to electroplate an iron to electroplate a copper spoon with the silver. To electroplate a copper spoon with the silver, a current of 0.5 amperes. A current of 0.5 amperes was passed for 30 minutes. Calculate the amount of silver deposited on the spoon. So during the electroplating of this copper spoon with silver, and you need to know the reasons for electroplating from Form 1 work, that is the combustion, that the reasons why we electroplate some spoons, the iron spoon, the copper spoon, it is either to improve the appearance of that spoon, and number 2, the major reason is just to prevent rusting. So the copper spoon here is electroplated using silver, such that it can prevent rusting. Here in this question now, we need the amount of electricity. We need here the amount of the charge of this metal. But first, during electroplating, silver metal is deposited at the cathode. So you need the question that at the cathode, where we have silver. So we have this is silver in the cathode. It just requires 1 electron, and then we have the silver solid. So we use this formula that we are calculating mass, that mass is equals to P. It is the quantity times RAM, that is the relative formula mass, and then you divide it by N, 10 times the number of Faradays. So in this case we have that M represents the mass, this one here represents the mass, then this RAM, you know from Form 3, this one represents the relative atomic mass. It is the relative atomic mass. Then we have N. It represents this one here. We have the charge on the metal in that case. And then we have F. This one represents the Faraday constants. So in this case here we have just 1 Faraday, which is equal to P, and 6,500 coulombs of that. So we have the value of so we need to get Q, the quantity. Quantity is given by, it is I times T, and this T must be in seconds. So in this case now, we have the current there is equivalent to 0.5. So we have this as 0.5 times 30 minutes. 30 minutes must be converted into seconds. So you multiply that one by 60, and that one will give us, we have this one as 900 coulombs. So we have 32. We have our n is equivalent to 1. And then we have the RAM, the relative atomic mass of that one is given as 108. And then we have a Faraday constant. One Faraday constant is equivalent to P, 96,500. Therefore, the mass of the amount of silver deposited now is equivalent to a quantity which is 900 multiplied by the RAM, which is 105, we divide by our n. In that case, it only requires one electron. So we have this is 1, and our Faraday's constant is 96,500. And that one now will give a mass equivalent to 1.007, in that case, grams. Question number 2. During the purification of copper by electrolysis, 1.48 grams of copper were deposited when a current was passed through them. So we don't know the amount of current that was passed through them. Was passed through the aqueous copper salvage for 2.5 hours. Calculate the current that has passed through the electrolyte, given that copper, the RAM of copper is 63.5, and 1 Faraday constant is equivalent to the 96,000 and 6,500. So in this case here, you need the question, the reaction that takes place at the cathode. During the electrolysis of copper using the aqueous copper 2 salvage, copper metal is deposited at the cathode. So the equation at the cathode here, we have the cathode, the copper metal is deposited at the cathode. So we have these 2 electrons. The oxidation, the reduction oxidation is losing the 2 electrons. So gain of an electron is oxidation. So we have an oxidation here. Then we have this is copper metal which is being deposited. Copper is being deposited there. So what you can see here that a brown solid is deposited, and then there is the cathode. Normally it reduces in mass. In some situations where you will be required to state the observation made here, there is a brown solid of copper metal is deposited there, and then we have the cathode increases in mass. So first we have that this one it needs 2 electrons, it needs 2 Faradays to deposit 1 mole of copper on this side. And what we have been given here, 1 Faraday is equivalent to 96,500. So in 1 Faraday is equivalent to 96,500, out of these 2 Faradays, because 1 Faraday is the same as 1 electron. So we can translate this one as 1 electron is equivalent to 96,500. Both of these 2 electrons. Therefore, our 2 electrons will be equivalent to be 2 multiplied by 96,500, and this one gives us 193,000 coulombs. The 193,000 coulombs now is required to deposit 1 mole of copper. So that one will deposit 63. That one will just deposit 63.5. So we require this one here that 193,000. This one deposits 63.5. Now we need the amount of quantity of electricity required to just deposit 1.48 grams of copper. So 1.48 8 grams of copper will be deposited by what amount of electricity? So that one will be equivalent to 193,000 multiplied by 1.48, and then you divide this one by 63.63.5. And if you calculate that one, it will give us 44.98. So we have this is 4498.26 grams, 0.26 columns. So this is the amount of electricity required to just deposit one mole of copper. We need to calculate our Q. Q is equals to Pi times T. So we have that Q is equivalent to Pi times T. And because now we are looking for the current, we can say that from here that the amount of current is equals to P. It is just the quantity of electricity, then you divide it by time. So we have this quantity here as 44,1098.26. Then we have time. Time we have been given 2.5. 2.5 hours is the same as 2.5. But that time has to be converted into seconds. So you multiply by 60 to convert it into minutes. Again by 60 to convert it that one into seconds. So the amount of current required is 0.4998 amperes. So this is the amount of electricity required. Now this is the current required. Calculate the current in amperes passed through the electrolyte. So during electrolysis, a current of 0.72 was passed through the aqueous magnesium salivate solution for 15 minutes. Calculate the volume of the gas produced at the anode. So the gas produced during the electrolysis of copper 2 salivate, we have the ions present, we have the magnesium ions, we have salivate ions, we have the hydroxide ions, and then we have the hydrogen ions. So at the anode, normally the oxygen gas is produced. So what can you observe at the anode is that there is the purples of a colorless gas, and that gas is just the oxygen gas. So oxygen gas is produced at the anode, and then at the cathode we have the hydrogen gas produced. So this one now, we need the equation that is producing the oxygen gas at the anode. The anode, now the equation at the anode, we have the hydroxide ions, and this one we have 2 moles of water, then plus the 1 mole of oxygen, and then we have 4 electrons. So in that case now, we need this equation here. The purpose of a colorless gas is just like the oxygen gas. And then you can see from here that it requires 4 electrons. So the volume is normally equivalent to the quantity times G. Do we have molar gas volume? So we have molar gas volume, then you divide it by N, then times the number of Faradays. So N, we have our N from here is equivalent, N is equals to 4. As you can see, this one requires 4 electrons. Then Faradays in that case is equals to P, 96,000, then we have 500 coulombs like that. Therefore, we need the quantity. The amount of electricity required is just I, in this case, times T, and the T must be in seconds. So that one gives us 0.72 multiplied by. So that one we have 15 minutes. So we have that 15 minutes must be converted into seconds. So you must have to multiply this one by we have to multiply that one by 60, and that one is giving us 648. So we have this is 648 columns. So we have everything there. We have the molar mass volume as 24,000 at room temperature, Faraday constant 96,500, then N we have as 4. So we can substitute here in that volume, in that formula. Our quantity is now 648 times the molar gas volume. The molar gas volume here is given us 24,000. So we have this one as for 24,000. Then you divide by number of electrons required is 4. So we have this is 4 times the Faraday constant, which is 96,500. And if you substitute that one very well, it will give you 40.29 cubic centimeter. So this one will give 40.29 in that case cubic centimeters. So that is the volume of the gas produced at the anode. Remember, at the cathode, the hydrogen gas is produced. Don't forget to follow my channel. Kindly subscribe, watch,